I'm not going to be in today. I'm going to have a procedure done, so unfortunately, I won't be in with you, but I will probably not be in tomorrow. Looking to be back in on Wednesday, fingers crossed. So I'm going to try to teach you a couple lessons here through a video, and hopefully they work and you can hear them and see them and make sense of it all. So you can kind of just pretend like I'm there. Just close your eyes. I know some of you do anyway. So I think it'll be all right. What we're looking at today are reflections, and we already did reflections just in general. We did symmetry. We constructed a reflection, but today we're going to look at reflections on the coordinate plane. So our goal, at least with the first set of problems, all the way up to looks like question 11, 12, and 13. I'm not quite sure why they were just not there. Sorry, all the way up to question 16 is figuring out which lines we can put on this graph so that the shape would fold over onto itself or the shape would reflect onto itself. What you can see in the first set of problems is we're given a shape like a trapezoid, and we want it to be able to fold over so it is symmetrical with itself. So this point over here in the corner would fold over to this point here would fold over to that point, and so on. But we're talking about lines on a graph, and one thing we have to remember is equations of lines. So I'm going to start with this one. Clearly you can see if we put a line down the middle of this trapezoid right here, over this red line, these 2 points in the corner would match. Same with the points on the bottom and all the other points that have a matching side across the mirror here. The question is, what is the equation of this line? And I know we haven't done any equations of lines on graphs this year, but you did do them before last year in algebra and the year before that, so I know you're familiar with this. Every line that is vertical on a graph has an equation of x equals a number. So this would be considered x equals 0 because it's going through the x-axis through 0. This line would be x equals 1. This would be x equals 2, 3, x equals 4, and so on. This would be x equals -1, x equals -2, and so on. You can see x equals -2 would not fold this shape over onto itself, and the only answer, moving the wrong one there, the only answer that would actually work would be this here, which would be x equals 0. So when it says write the equation of the line of reflection, we're going to want to write x equals 0. So x equals 0 is the answer to this question. It's the line that this shape would fold over and land on itself. If you look at question 2, we have a parallelogram, and what we learned about parallelograms is they don't fold over at all and have any lines of symmetry. So the answer to this would be none. Parallelograms have no lines of symmetry, and you might think some of these diagonal lines would work, but if you actually draw them in, this corner would fold up over here and it wouldn't quite land on top of the corner that you see there. Number 3. Okay, so number 3, we have, let me just get rid of this draw thing here. Number 3, we'd be looking at some vertical line that would, match the shape over. And if we put this vertical line here at 1, you can see it doesn't quite work. And if we put it over here at 0, we can see it doesn't quite work. So this one's kind of strange, but it would have to go through right here, which would be right in between. And if you were to try to figure out the equation of this line, think about it. It looks like it's a vertical line at x and going through about a half. So this would be the vertical line of symmetry, but there's also a horizontal line of symmetry, which we would have right about here. And that one would also be sort of halfway through. See if I could just make this a little bit easier for us to see. I don't know, maybe it's going to be too difficult, but anyway, never mind. It's just sort of not exactly where I want it. Maybe that's a little bit better. So the two equations that we have here, well, this would be an x equals a half. So I'm going to write that equation in. 0.5. And this horizontal line, these are y equals equations. So when we look at equations for horizontal lines, like this would be y equals 0, y equals 1, y equals 2, y equals 3. This right here would be y equals 3.5. So sometimes you do get lines that are not quite in the middle. So this would be, or not, sorry, not quite on the lines. They are in the middle. That's what I meant to say. But that would be y equals 3.5. So that's what we're doing here. We're trying to figure out these lines and exactly what their equations would be. So that one there, not too difficult, but it's kind of strange. Take a look at number 4. Again, rectangles have 2 lines of symmetry, and here we'd be looking at a vertical and horizontal line. Why don't you see if you can figure it out like we did back here in question 3, and then also try number 5. So I'll give you a second, we can pause the video and you can try those out. All right, so we've got, in number 4, looks like we'd have a line right about here. And that one's tough to see, but it would be 2.5 boxes and 2.5 boxes. So we're looking at y equals negative 1/2. Y equals negative 1/2. Negative 0.5. And the vertical one would be, keep grabbing the wrong thing here, hold on. The vertical one would be right about here, which would be y equals 1.5. Sorry, x equals 1.5. All right. In number 5, same thing. We've got some vertical lines. This one's nice and normal, meaning we've got a nice whole number. And same with the horizontal. And you can see that the 2 answers here would be x equals 4 and y equals 7. All right, moving on. Another rectangle question. We've got 2 more lines that would work here. And let's see what we have. Okay, let me grab these here. Looks like we'd get this vertical line. Move it over a little bit. And we'd have this horizontal line here. And slide that down for you so you can see it. Question 6. We'd have lines at x equals 2.5. Vertical here. And y equals negative 3. That's a really bad looking 3. Let me try that again. That's a little bit better. Okay. Finally, we've got this last trapezoid, and remember with trapezoids, they only have 1 line of symmetry, and we would have this line right here, vertical line, and that would be x equals 1. Okay, next section, it says write a rule to describe the transformation. So these are all reflections that we're looking at today. So I'm going to type this out, make it a little easier when I go to give you the answer so it doesn't look so messy. But again, we're trying to figure out how can this black triangle, black figure, in this case it's a quadrilateral, reflect over to the blue one. And if I borrow this line again here, you can see, for example, that this one would be a reflection over this line. If I were to ask you what this line is, you could tell me it's y equals 0, but you can also describe it simply as the x-axis. So there's 2 answers for this one. It would be the reflection over, and we would say here, let me just back this up a little bit, reflection over the x-axis, or we could say it's reflection over y equals 0. Okay, so this is the line right here. Number 9, you can see that if we had a vertical line right here, the black triangle, each point would flip over. It's the same distance perpendicular across. And this line is at negative 1, 2, 3. So this would be a reflection over, and we have x equals negative 3. Finally, number 10, we would have a horizontal line right here that the quadrilateral would reflect over. So the blue and the black would reflect over this line, and each of these points would match up, k to k prime, f to f prime. Looks like that's j to j prime and v to v prime. And this would be a reflection over And this horizontal line is at y equals 2. Okay, so what you're going to do here on the back is give these a try. You've got 11, 12, 13, 14, 15, and 16. See if you can come up with the answers. I'll make another video going over that, and then I'll explain what's going on down here. These are actually reflections of points over the different axes, and there's some rules for these. And we saw rules for rotations. We're going to teach you some rules for reflections, and then you'll work through these, and you should be all set. All right, so give these a try, and in my second video, I will have the answers for you. All right, guys, thank you.